Welcome to my channel. This is Krishna Swami. Okay, in our course syllabus, our first chapter name is Units and Measurements. So, in this chapter, already we learnt about the following topics. What are there? So, our first topic is physical quantities. Physical quantities. And the next one is units and system of units. System of units. So next one is dimensional analysis. So next one is errors in measurement. So now we want to discuss about the dimensional analysis. Already in our previous class we learnt about the dimensional analysis. In this dimensional analysis, already we learnt about what is the definition of dimensions and what are the rules of the dimensions and how can we write the dimensional formula of physical quantities, and we also learnt about the limitations of dimensions. So these are learnt in our previous class. So today we will discuss about some non-mechanical dimensions of some non-mechanical physical quantities. So before we will write about the dimensions of non-mechanical physical quantities, once again we revise the how can we write the dimensions and what are the dimensions, how can we understand the dimensions. So dimensions means the dimensions of a physical quantities expressed in the exponents or powers of the units of base quantities or fundamental quantities are known as a dimensions. And in these dimensions, what are the rules of dimensions? So the dimensions the dimensions can be write in a square brackets, and there is we neglect the numerical values and trigonometrical values. So these are the rules of the dimensions of a physical quantities. Okay, in this class we want to write some dimensions of some non-mechanical physical quantities. So now we will see what are there. So first one, so we want to write the dimensions of heat, and the next one is latent heat. The dimensions is latent heat. So next one is heat and latent heat. Next one specific heat capacity. And next one we want to write about the dimensions of gas constant. Real gas constant. R. And also we want to write about the dimensions of the Boltzmann constant. So next, and also we want to write the dimensions about the Wien's constant. So, Wien's constant. And also we want to write about the dimensions of heat, latent heat, specific heat capacity, gas constant, Boltzmann constant and Wien's constant, and next the mechanical equivalent of heat. Mechanical equivalent of heat. So next we also write the dimensions of temperature also. So temperature. So these all physical quantities are belongs to thermodynamics. So now we want to write the dimensions of these thermodynamic physical quantities. So first one is temperature. The dimensions of temperature. So already we know about what is temperature. Temperature is a fundamental physical quantity. So it cannot be derived from any other physical quantity. So its units is, or it measures in Kelvin. So these dimensions are M0, L0, T0 and K1. So what are the units of temperature? Units of temperature is Kelvin. So this is Kelvin. So next we want to write the dimensions of heat. So heat means heat. It is a form of energy. So it has the dimensions of energy. So what are the dimensions of energy? Already we learnt about our previous class. So dimensions of heat is M1, L2, T minus 2. So what are the units? So a energy aina manaki units emunte joules. So the units of heat energy is joule. So next we want to write the latent heat, the dimensions of latent heat. So this is very important to in our examination point of view. So latent heat. So latent heat denoted by L anko. So latent heat means the heat energy for mass is called as a latent heat. So now we can write it as Q, the heat energy Q by mass. So already we know about the dimensions of heat. So what are there? M1, L2, T minus 2 by, so what is the dimensions of mass? So mass is a fundamental physical quantity. It cannot be derived from another physical quantity. So the units of mass is kg. So that means that mass is denoted by M1. So now we can write it as, so this mass get cancelled. Therefore the dimensions of latent heat is L2, so M0, mass, dimension of mass is 0 and dimension of length is 2 and dimension of time is minus 2. So these are the dimensions of latent heat. So what are the units? So units of latent heat is here heat energy measured in the joules for kg. Mass means kg. So joule for kg inverse ga we can write it as the units of latent heat is joule and joule for kg. So it is the dimensions of latent heat. So next we want to write about the gas constant, dimensions of gas constants. So dimensions of gas constant. So we can write the gas constant, dimensions of gas constant. So denoted by symbol R. So already we know about our ideal gas equation. From our ideal gas equation, PV equal to nRT. Here R is a gas constant. So in this form we can get it as R equal to PV by T. Let n equal to 1 mole. So now, so that equal to, therefore, the gas constant R equal to PV by T. Here P is a pressure and V is denoted by volume and T is the temperature. So now we also know about the dimensions of the pressure. So what are there? M1, L minus 1 and T minus 2. T minus 2 into. So what are the dimensions of volume? Volume means length into breadth into height. That means length into length into length. So L cube. That means L3 by. So what are the dimensions of temperature? So already we learnt about the dimensions of temperature. Dimensions of temperature is measures in Kelvin. So we can take it as a K. Now we can write it as the dimensions of gas constant are equal to, so M1, here L minus 1, L plus 3. So minus 1 plus 3 becomes L power 2. That means L2 T minus 2 and Kelvin inverse. So these are the dimensions of gas constant. If we can observe deeply, so this is M1 L2 T minus 2 denote the which dimensions? It shows the which physical quantity dimensions? So it shows the dimensions of energy. So energy is measured in joules. So we can simple ga మనం గుర్తుపెట్టుకోవాలంటే joule per Kelvin. So the units also we can write it as joule. The units of gas constant is joule Kelvin inverse. So these are the units of gas constant. If we know the units of joule constant, the units of gas constant, we directly write it as, already we know J, joule. Joule means the dimension, it denotes the energy. So first we want to, already we learnt about the dimensions of energy. So simply we can write it as M1 L2 T minus 2 by, so for Kelvin, simply we get it as dimensions of gas constant. So if we know the units of these any physical quantity, we get it as simply, or we can write it as simply the dimensions of that physical quantity. So next one is Boltzmann constant. So it is also denoted by B equal to or K equal to R by N. Here N is a Avogadro number. So simply the dimensions of R is, so So n equal to 1 here. So same as m1, L2, T minus 2 and K minus 1. So the dimensions of gas constant and the dimensions of Boltzmann constants both are equal. So units are so both are equal. Next, Wien's constant. Now we can write the dimensions of Wien's constant. So Wien's constant. So Wien's constant equal to lambda m into T. T is a temperature, lambda is a wavelength. So now we can write it as the dimensions of Wien's constant is, so there is m, no, there is a L, yes. What is the dimension of L? 1, because the wavelength is measured in meters. So next, T, there is a no time. T means temperature. So K1, temperature measures in Kelvin. So therefore the dimensions of Wien's constant is m0, L1, T0, K1. So simply write it as L1, K1. So these are the dimensions of Wien's constant. These are the dimensions of Wien's constant. Next, we want to write the dimensions of mechanical equivalent of heat. So mechanical equivalent of heat. So simply we define the mechanical equivalent of heat means the amount of work for heat energy. It is called as a mechanical equivalent of heat. So now we can write it as the dimensions of this quantity is, so we know the, so work and energy have a same dimensions. So simply we write it as, so what are the dimensions of energy? So already we know about it. M1, L2, T minus 2 by, so Q means heat energy. So heat energy also same dimensions. So M1, L2, T minus 2. Simply they are cancelled out. So they can be get it cancelled. So that means now how can we write it? The dimensions of mechanical equivalent of heat. M is 0. M means mass. The dimension of mass 0, dimension of length 0, and dimension of time is 0. But it have a units. So what are the units? So joule for calorie. So work is measured in joule and heat energy here measures in a calories. So that means units of equivalent of heat is joule calorie inverse. So these are about the dimensions of the dimensions of a physical quantities in the thermodynamics. So next we want to write about the dimensions of a physical quantities in electricity. Now we can write the dimensions of the physical quantities in a electricity. Okay, in this electricity, so how can we write the dimensions of the electricity? So first of all, in this electricity, we can write the following, the dimensions of the following physical quantities. So first we want to write it as the dimensions of current, and the dimensions of current. Next, the dimensions of charge. Next one is potential electrical potential. Electric potential. Electric potential. So next one is charge. Electric field intensity. Electric field intensity. So next one is resistance. And next one, resistivity. Next one is conductivity. The next one is capacitance. The dimensions of capacitance. So next one is current, charge, electric potential, electric field intensity, and resistance, resistivity, conductivity, capacitance. And also we want to write the dimensions of dielectric constant. Dielectric constant and electric permeability in free space. Electric permeability in free space. And also we want to write the dimensions of electric permeability in free space. And next one is current, charge, surface density of charge. Surface density of charge. Next one is dipole moment. Okay, now we want to write the dimensions of a physical quantities in electricity. So first of all, we want to write the dimensions of current. So now we want to write the dimensions of current. Okay, already we know about the current is a fundamental physical quantity. So it cannot derive from any other physical quantity. So the current is measured in ampere. So therefore the dimensions of the current is m0. So mass is 0, length 0, time 0, and ampere 1. So what are the units of current? Units of current is ampere. Current measures in ampere. So these are the dimensions of the current. So next one is electric charge. So charge. Electric charge. So charge, it is a derived quantity. So now we can derive this quantity from using the fundamental quantities. So charge can be derived as Q equal to IT. That means current into time. So now we can write the dimensions. So current is a fundamental quantity and time is a fundamental quantity. Now we can easily write the dimensions of the charge. So that implies here mass, the dimension of mass is 0. Dimension of length is 0. So and dimension of time is 1. So current is ampere. So these are the dimensions of charge. Simply it can be written as 80 also. So what are the units of charge? So the charge measures in coulomb. Coulomb. Or we can write it as also ampere second. Ampere second. Ampere second. We can write it as ampere second because the charge Q equal to current into time. Current is measured in amperes and time is measured in seconds. Now we can write the dimensions of the electric potential. Now we can write the dimensions of electric potential. So how can we write the dimensions of a electric potential? Electric potential V. So the electric potential, what is the definition of the electric potential and how can we derive the electric potential? So electric potential nothing but the work per unit positive charge is called as a electric potential. It can be expressed as a V equal to work per charge. Work per charge. Now we can write it as the dimensions of work electric potential. So that equal to, already we know the dimensions of the work. What are there? M1, L1, T minus 2. Sorry, L2, T minus 2 by. So already we solve the dimensions of the charge. So Q equal to. So what are the dimensions of charge? Ampere second. Ampere into time. So therefore we can write it as the dimensions of the electric potential is M1, L2, this T, 1 is cancelled. Therefore T minus 1 and ampere minus 1. Sorry. Here, so this T becomes minus T here. So we can write it as M1 L2 T minus 3 and A minus 1. These are the dimensions of electrical potential. So what are the units of electric potential? So electric potential can be measured in, so units of electric potential is volt. Electric potential is measured in volt. So now we can observe these dimensions. So this is the dimension of power. So power can be measured in watt. So simply we can write it as, so these units also write it as V equal to power P by I. So then we know this equation directly, we can write it as the dimensions of P means power. So already we know the dimensions of power M1 L2 T minus 3 by I. I means current. Current measures in amperes. So these are the technique. Now we want to write the dimensions of the capacitance. So first of all, we want to derive the capacitance. So capacitance can be derived as a C equal to the unit charge for electric potential. It is called as a capacitance. So C equal to the charge for potential. So now already we know about the what are the dimensions of charge. The dimensions of charge is A and T, ampere second. So now we can write it as AT. By what are the dimensions of potential, electric potential? Already we know about the electric potential V equal to P by I. That means watt for ampere. So we know the dimensions of watt. How can we write it as M1 L2 T minus 3. So next ampere minus 1. So watt for ampere. Here I can take the dimensions from this formula. Electric potential dimensions can be taken from this formula. So now we can write it as the dimensions of capacitance is M minus 1 L minus 2. So here the minus 3 becomes numerator, so plus 3. So then T power 4 and A 2. The minus 1 becomes plus 1. So therefore the dimensions of capacitance is mass. Dimension of mass is 1. Dimension of length here minus 2. Dimension of time here power 4. And here dimension of current is 2. So these are the dimensions of the capacitance. So what are the units of capacitance? So capacitance can be measured in farad. So units of capacitance is farad. So it can be measured in farad. So next we want to write the dimensions of dielectric constant. Dielectric constant. So dielectric constant can be defined as the permeability. So dielectric constant. Dielectric constant equal to or equal to epsilon by epsilon naught. So permeability in medium by permeability in free space. So it is a dimensionless quantity. That means dimensions of mass is 0, dimensions of length is 0, dimensions of time also 0. So these are the dimensions of the dielectric constant. Dimensions of dielectric constant. So next we want to write the dimensions of the electric permeability in free space. Electric permeability of free space. It is denoted by epsilon naught. Already we know about the Coulomb's law of electrostatics. From Coulomb's law of electrostatics, so F equal to 1 by 4 pi epsilon naught into Q1 Q2 by R square. Now we want to write the dimensions of this permeability epsilon naught. So then we can write it as epsilon naught is equal to, so it will come to this F plus. So F will become the denominator. Q1 Q2 by F into R square. So this 1 by 4 5, it is a numerical value. Already we know about the rules of the our dimensions. So we can neglect the numerical value. So then here we can neglect the value of 1 by 4 5. So this is our formula. Now we can write the dimensions of the epsilon naught. So permeability. Here Q1, Q2 is charges, electric charge. F is force. R is the distance between two charges. So distance. That means we can take as a length. Take it as a length. So now we can write it as a Q square. Charge square Q1 into Q2 by F into R square. Already we know about the dimensions of the charge. Simply dimensions of the charge is ampere into second. That means A into T. So A T whole square by, we also know about the dimensions of force. What are there? M1, L2, T minus 2. So dimensions of M1, L1, force is T minus 2 into, here R is a distance, that means length square. So into L power L of 2. So now it can be written as AT, so A square T square divided by mass of 1, length is 1, so the dimension of time is 2 and dimension of length is 2. Here L1, L2, L3, 1 plus 2 is 3. So this equal to, so here minus 2 becomes 2, numerator it can be plus 2. So now we can write it as ampere 2 and time 2, M1, L3 and T minus 2. So now we can write it as M minus 1, L minus 3 and T 4 plus 4 and ampere 2. So these are the dimensions of a electric permeability. So therefore the dimensions of electric permeability is M minus 1, L minus 3, T plus 4, ampere plus 2. So these are the dimensions of a electric permeability in free space. So that is epsilon naught. So next, what are the units of this electric permeability? Here we can write it as a units. So here Q square means Coulomb square. Units. So Coulomb square for Newton meter square. So it can be written as the units of electric permeability is Coulomb square. So N minus 1, M minus 2. So Newton meter square. Coulomb for Newton meter square. These are the units of electrical permeability, epsilon naught. Next, the surface density of a charge. That means, so now we want to write the dimensions of a dipole moment. Dipole moment. dipole moment. So now we can write how we can write it as its formula, the formula of a dipole moment. So dipole moment, it is denoted by P. P equal to charge Q into 2A. So this is the formula of the dipole moment. A is measures in meters. So now we can write it as, we know the units of charge AT, and the 2 can be neglected, into, so A means length or area. Okay, now we want to write the dimensions of a dipole moment. Dipole moment is denoted by P. So P equal to charge Q into 2A. Here A is a length, Q is a charge. Already we know the dimensions of the charge. What are the dimensions of charge? Charge means ampere second. That means A into T. So here we can write it as AT, and we also neglect the numerical values 2. So numerical values are neglected according to our dimensional formulas rule. So AT into L. Now we can write it as, the dimensions of dipole moment is M0, L1, T1 and A1. So mass, the dimension of mass is 0, dimension of length is 1, dimension of time is 1, and dimension of current is 1. So these are the units of dipole moment. So what are the units of dipole moment? These are dimensions. So units of dipole moment is, Q means charge. Charge. What is the units of charge? The units of charge is coulomb. So coulomb. What are the units of length? Meter. So coulomb meter. It can be written as coulomb meter. So these are all about the physical quantities. The dimensions of a physical quantities in electricity. So next we want to write the dimensions of the physical quantities of a magnetism. Okay, so in our next class. Okay, thank you for watching. If you interested, you can like it my channel and subscribe my channel.